try to understand here how is the procedure for finding the branch currents and branch voltages using the tie-set matrix method. Draw the oriented graph for the given network. Means from the given network, first we have to prepare this oriented graph. This is step number 1. Then select a tree and prepare a tie-set. Means out of that given oriented tree, we have to select one of the tree, and then we have to prepare the tie-set matrix. Prepare the tie-set matrix, which is BF. Is it right? Which is tie-set matrix. Construct the branch impedance matrix ZB, given network, and order of this matrix will be B into V. First we will select the tree, we will prepare the tie-set, and we will prepare the tie-set matrix, then we will prepare the ZB, that is the branch impedance matrix, and then we will prepare tie-set impedance matrix ZT using the relation. Because already I have discussed the ZT is nothing but BF into ZB into BF transpose. Using this equation, we are trying to find out this value of the ZT. And if the value of ZT is known, we will find out the IS or VS. Here in this case, prepare voltage source matrix VS. We will prepare the VS. This is VS1, VS2, VS3 and so on. And what are the polarities of this, or what are the guidelines for the polarities of this? The elements in the VS matrix are taken as a positive if branch current enters into the positive terminal. You see here, if this is the branch, and if the current is entering into something like this, this is the positive terminal of the battery. The elements in the VS matrix are taken as a positive if branch current enters the positive terminal of the voltage source. If current is hitting to the positive terminal, in that case that entry will be taken as a positive, otherwise that entry will be negative or 0. Here if it is entering into the negative terminal, in that case entry will be the negative, and if that source is absent in that particular branch, its entry will be 0. That is the preparation of this source matrix. I will discuss with the example. And then next we will prepare the KVL equilibrium equation or KVL equation. ZT into IT, which is equal to minus BF into VS. Minus BF into VS. And if we know this equation, in that case ZT is already calculated by us, BF is already calculated by us, VS is already known to us, then we are able to find out the IT. Means indirectly we are able to calculate, the loop currents. Means we are able to find out the I1, I2 and I3, which is generally known as the tie-set current. Means we are able to find out this value of the loop current or tie-set current. If we know the tie-set current, we can find out the branch currents. Actually, this value is not I1, I2, I3. Actually, it is IX. This is IY and IZ as per our notations. And then we will find out the branch currents. This here, in this case, branch current in the first branch is I1, current in the second branch is I2, current in the third branch is I3, and so on, using this equation. And similarly, the voltages across each branch is calculated by using this particular formula. This VB is equal to ZB into IB, as it is VS. These are the ways of this calculation, which is nothing but procedure for finding the branch voltages and branch current using this tie-set matrix. Is it right?